So in this video we're going to look at constructing simple graphs. A graph is a way for us to represent data in a visual form. Graphs can also be used to display data showing how one variable affects another. There are many different types of graphs that are used in engineering. The most basic is a straight line graph. In a previous lesson we've talked about how the cutting speed is directly proportional to the spindle speed when we're turning on the lathe. This data can be displayed in a straight line graph showing the corresponding values of V and S. This graph shows three separate lines that relate to the diameter of the rotating workpiece. So there's a 20mm one in green, 30mm in blue, and a 40mm diameter in red. The graph can be a useful tool for identifying the required spindle speed. For example, if you've got a cutting speed of 15 meters per minute and a diameter of 30mm, you can look at the graph and see the required spindle speed. So if we go up the y-axis, the 15 meters per minute in purple here, follow the dotted line across to the 30mm diameter line, and then go down, we get a spindle speed of 160 RPM. You can also do this the other way around, so if we have a spindle speed of 275 RPM, if you go along the x-axis to this orange line, you go up to the 40mm diameter, and then across to the y-axis, that gives us a cutting speed of 34.6 meters per minute. And you can check if that's the correct speed for the diameter and the material that you're using. So as well as straight line graphs, we have line graphs. Line graph is often used to show data over time. Points are plotted on the graph and these are joined together by a line. It's not a single line, it's not a straight line, it'll be a series of lines connecting each point. So the graph here is shown as a good example of this, and this is a graph from Al Gore's An Inconvenient Truth, and it shows a correlation between the concentration of carbon dioxide in the Earth's atmosphere and global temperatures over the past 600,000 years. So as you can see by the graph, there's two graphs on this, one above the other. As the carbon dioxide rises on the top, the temperature rises as well. And it goes along, and this graph was used to show the future predictions of global warming, because as you come to the very end of the graph in modern days, you can see there's a massive spike here in carbon dioxide, and they expected the spike in temperature to follow as it has followed during the last 600,000 years. So plotting data on a graph. So here we've got some data that shows the corresponding values of voltage and current in an electrical circuit. This data can be plotted as a graph. So to create the graph, a point is plotted for each pair of corresponding values. When all the points have been plotted, they can be connected with a line. As the two variables in this set of data are directly proportional to each other, this line on the graph will be a straight line. The convention is to plot the dependent variable, which is y, on the y-axis, or the vertical axis here. In this case, that is the current of the circuit. And the independent variable, in this case the voltage, is plotted along the x-axis. So one way to remember this is the data you know for sure is plotted along the x-axis, so the voltage has been obviously changed by someone to 1 volt, 2 volt, 3 volt, 4 volt, and then they've recorded the current in that circuit from the voltage. So the data you know for sure goes along the x-axis, and the one you're unsure of or you're trying to find out goes along the y-axis. So using the data below here, showing two variables that are again directly proportional to each other, we're going to create another straight line graph. So this is temperature and resistance in a component. So to plot the graph, we need to determine the resistance of the component at 0 degrees Celsius. The graph should be a straight line that will not pass through the origin of the graph. This is the point where the temperature and resistance are both 0. So by looking at the graph, we can suggest a relationship that allows us to find the resistance of the component at any given temperature. So the relationship can be written with this equation here. And if we want to check that this equation works, we would insert different pairs of values from the table and compare the results.